record this. I was just opening the recording software because I record these sessions for final exam preparation. Final exam, we don't have to do the same thing. So you just have to watch this one. Then we'll work on something different, okay?
Okay.
Okay, you said what do you have when you factorize this?
Open bracket x minus 1, close bracket, open bracket 3x minus 2.
This side is 3x, this side is x. Then when I look at this, the first thing that we need to focus on is the factors of 2 that when you add or subtract, they give us the middle term of 1. Those factors is 2 and 1, right?
And
then you're gonna check where to put the 1 and where to put the 2. For example, let's say I decide to put my 2 this side. Look at this. 3 times 2. What is that equals to? It's 6, right? Then you ask yourself, is 6 close to this middle term? Nope. So 6 is very far. Then the 2 won't work that side. But 2 times 1 is 3. 3 is close to that 1. So the best thing to do is to put the 1 this side and then the 2 this side. Then you take the sign, and then this one will be positive, this one will be negative. Are you with me on that?
yes.
Okay. So
Wait,
there,
why is the 2? Oh, the 2 must be positive.
I'm listening.
Never mind.
Oh, okay. Okay, so what I'm going to do next, I'm gonna say this is the 3x plus 2. This is equal to 0, or the x minus 1 is equal to 0. When I solve this side, we get x, it's 1. The other side, 3x, it's minus 2. Divide both sides by that gives us x to be minus 3 over 2. But now, they said x must be an element of what? X must be an element of integers. It's 1 an integer.
Yes.
It's 1 an integer.
Is it not?
Okay, what about the minus 3 over 2? It's minus 3 over 2 an integer. It's a fraction. Can you see that?
Yes.
So therefore, we're going to reject
Yes.
that guy. X must not be equals to minus 3 over 2. Are you happy with that?
Okay.
Okay, let's move to the next question. So on this one, when I look at what you are given fractions. This is fractions. We need to work out to this thing. And the first thing that you need to do is to find your LCD, the lowest common denominator. And when I look at this, the lowest common denominator is just the product of your denominators, but don't repeat the terms, okay? So when it's like this, I have x plus 1, and then I have x minus 2. So I don't have to say x plus 1 again. You just have to take one of these two. You understand?
Yes.
Then your LCD will be x plus 1. So from there, you need to take this LCD, multiply each term with the LCD.
2 seconds.
I'm listening. Are you saying something? Sivo, you're still with me?
So can you please give me 2 seconds? I'm coming back.
Okay. 100%. So now, as I was saying, you take this LCD, you multiply every term, and I'm not going to jump a step. I'll move this step by step. So I'm going to take my LCD, which is x plus 1, into x minus 2. I'm going to multiply the first term there, which is 1 over x plus 1. Then you take your LCD. You see this plus sign here? You're going to bring it down here and say plus. Then you put your LCD, which is x plus 1, into x minus 2. You multiply the second term, which is 3 over x minus 2. close the bracket, you put your equal sign, you take your LCD x plus 1. What you do on the left-hand side, you also do on the right-hand side. Then from there, you can just say this is x plus 2 over x plus 1. So you're going to look at the like terms. Okay, so if you have a term here, like for example, these terms on your LCD, they will cancel the ones on your denominators, and then this x minus 2 will cancel that x minus 2. Here, this x plus 1 will cancel that x plus 1. So now you need to multiply out those brackets. Whatever that you have left, you're going to multiply the 2, meaning that you're going to take the x minus 2, multiply that by 1. Then you move, you take the x plus 1, you're going to multiply that by 3. Then equate this to what? The x minus 2, which will be multiplied by x plus 2. So now, this is just x minus 2. Then I'm going to say plus, multiply every term inside the bracket by 3, which gives us 3x plus 3. This is equals to, I'm going to use the FOIL method and multiply out the bracket here. Do you want to try that one? What do you get when you use the FOIL method to multiply these two brackets?
X squared plus 1x plus 2x plus
X squared plus, did I hear 1x?
Yeah, aka just x.
Remember, it's x times x, which is x squared, then x times 2, which is 2x, not 1x. You understand?
Minus what? So, plus 2.
Yes, that will be
I misread.
plus 2x. I know these things are easy, but you, like most of the time, you guys make mistakes and you start losing marks. Then this will be plus 2 minus 2x minus 4. Then look at these two. These are the like terms with different signs. So that will be 0, and then I'll be left with x squared minus 4. So I'll try to move everything on one side. This side, I have the x that I need to add with the 3x. That will give me 4x. Then we have the minus 2 that should be added with the 3. That will give us a positive 1. So this side, I'll be left with 4x plus 1. It's equals to, on the other side, I just have x squared minus 4. Right. So what I'm going to do from this, I'm just going to try and move everything to one side. Already the x squared this side is positive. So this will be x squared. Then I bring the 4x this side to be minus 4x. Then I'm going to take the minus 4 and the minus 1. This guy will come here to be minus 1, which will give us minus 5. This is equated to 0. Therefore, what happens next is that we can just open the brackets and solve for x. So look at this. This will be x. This is x. Then the factors of 5 that when you add or subtract them, they give us the middle term of 4 is just 5 and 1. So this will be 5 and 1. Then you take the sign of the middle number. You give it the bigger number. And then this one will just be positive 1. Are you with me on that?
Yes.
So this gives us x to be 5, or the value of x, it will be minus 1. And that's it for this question.
Okay.
Are you happy with that?
Yes.
Right. So you can also check your answer is fine. You can check, reject, do some of the rejection, it's fine. Okay. Let's look at this one. So this question, it has to do with exponents. So I'm going to first change the 32 and write that as base 2. Tell me, what is 32 when we write it as base 2? What is that equals to? Do you know how to use your calculator to write a number in terms of what do you get?
Shift fact 2 to the 5.
Exactly. So this will be 1 over 2 to the 5. So now the 2 to the 5, I can change this because I need the base to be the same on both sides. So I can write this as 2 to the minus 5 because if I have 1 over x, where is this coming from? This is coming from x to the power negative n. So this tells you that if I have something like that, I can go back and apply the law in reverse. So if I have 1 over 2 to the power 5, this is the same as 2 to the power minus 5. Therefore, the base are the same. This tells you that the exponents are also equal. Divide both sides by that minus 2. You'll find your x to be positive 5 over 2. That's your final answer.
Okay.
Do you have a question on this one?
No.
Okay, let's move to the next one and let's see what we have on this one. So now, I think we did talk about the sets last time, ne?
Yes.
We did talk about the set. First thing first, isolate the set. You need to make sure that this guy here, you're going to put this guy on one side of the equation. To do that, you move the x, you bring it this side, it becomes negative. So this will be the root of x minus 2, and this is equal to 4 minus x. Then remove the square root because when you square both sides, I think when you square both sides, there's definitely a mark for that. Just for squaring both sides. In most cases, if this, in fact, this is 5 marks. For isolating the root, they might also give you a mark for that, okay? So now I'm going to square both sides to get rid of that squared. And then now, what do we get? This is x minus 2, it's equals to. So I need you to expand the bracket here. Tell me what you get. When you multiply out the brackets, what do you get?
Okay, I'll do just right here. Um, 16. 16 negative 8x negative 2 negative x squared.
Is it? Can we say minus x times minus x to be negative x squared?
Oh, positive x squared.
Exactly. You need to pay attention to signs. So I have just noted two things in this lesson. The first one, what was the issue on the last one? Oh, you missed the sign even on the last one. You missed, oh, you forgot that it was 2, you said 1. Then this will be positive x squared because I need to note these mistakes down so that I can keep reminding you. Né? I know some of the things you know how to do them, but when you get in an exam, you keep making the mistakes that will cost us the marks. Now you'll be giving away those marks. So now I need to arrange this thing in the correct form. So I just have to move everything to the other side. This will be x squared. Therefore, I'll have the 8x. This x will come this side to be minus, which gives us minus 9x. Then I have 16. The 2 comes this side to be positive, which gives us positive 18. This is equal to 0. Can I factorize this 100%? We can definitely factorize this and equate this to 0. So when we factorize, we're going to put the x on both sides. We need the factors of 18 that when we add or subtract them, they give us 9. So the factors of 18 is 1 and 18 is 2 and 9 is 3 and 6. Okay, so on these factors, I need two factors that will give me the middle. When I add them, they give me what? A 9. These are the factors that I'm looking for. The 3 and the 6. The 6 and the 3. So I need to decide. Since it's positive, both of them should be negative because it's positive 18. To get positive 18, both of these vectors should be what? Negative. Therefore, you can say your x, it's 6, or the value of x, it will be minus 3 or positive 3. But now I have a question for you. Are we done solving the question?
No.
What should we do next?
Sub back in.
Exactly. We need to check our solution. We need to check. So if x is equals to 6, I need you to come on this equation. Where there's x, put 6. Tell me if left-hand, if you get your answers 4. Use your calculator, say 6
wait.
plus the root of 6 minus 2. What is that equals to?
8.
You get 8. Therefore, left-hand side is not equal to right-hand side. I'm going to reject 6. Then do the same for 3. What do you get if you substitute 3 where there's x on that equation? What do you get?
4.
You get 4. Therefore, I'm going to take this one, but we reject x. X must not be equals to that 6. Right. Another one, when I look at this one, another one, this is easy 5 marks. I'm not sure. Do you want to try this one first or should we work on it?
Let's work on it.
Okay. So remember, when you have this type of equation, the aim here is to isolate the x. So I'm given 5 x to the power minus 2 over 3. And this is equated to what? 80. So the aim is to isolate x. I can first start dividing both sides by 5. Therefore, this gives me x to the power minus 2 over 3. It equals to, what is 80 divided by 5? What do you get?
16.
Okay, so you get your answer as 16. Now, we need to isolate x. Tell me, how can we remove that exponent minus 3 over 2? Do you have a way that we can use? Because in most cases, they say without using a calculator. So when they say without using a calculator, look at this. This is 5 marks. So this tells you that there's still work to be done. How can we remove that exponent?
I'm not sure. By timesing the other side as well by that.
We're going to multiply the other side by the reciprocal, meaning that to get rid of this one, I'm going to multiply. I'm going to take this guy here, multiply that by the reciprocal, which is negative 3. I'm not sure if you can see that, but let me just write it properly. So it's going to be negative 3 over 2. Negative 3 over 2. So that this cancels that, this cancels that, okay? Therefore, what you do on the left-hand side, you also do on the left-hand side. So now I have x, which is equal to minus 3 over 2. Then we'll take it from there. Please don't punch a calculator without using a calculator. This is, I'm going to first change the 16. I know that the 16 is 2 to the power 3. No, not 2 to the power 3, but 2 to the power 4. And then this is to the power minus 3 over 2. So the next thing, you just have to multiply out your exponent. So this is 4, which is multiplied by negative 3 over 2. So 2 goes into 4 2 times. So 2 times 3, that's minus 6. So this will be minus 6. So this guy here, we can write that as x to the power negative, x is equals to 2 to the power negative 6. And then you write this as a positive exponent. X is equals to 1 over 2 to the power 6, which is just 1 over 64. Then that's your final answer. Okay, they want it as what? They want you to give them the answer in these steps, because you can see that they can't just say 5 marks where when you get to this step, you punch a calculator. How are you going to collect the marks? There's a mark for simplifying to that part, and there's another mark for the final answer. And then, yeah, and that's it for this one. Are you happy with the solution? Do you have any question?
No.
Okay. 100%. Remember last time we talked about an inequality. So I think it's best if you try and solve this one. Let's see if you remember what we did on inequalities. Can you try work on this one?
Okay.
This one is 4 marks. You should spend 4 minutes for this question. Not less than 4 minutes. So by 33, you should be done working on this one. Now your time is up. Tell me what you have.
My final answer is x is element of included 1 to infinity, or x is an element of included 2 to infinity.
Wait, you said 1 to what? 1 to infinity.
Yes.
Like this. Then what's the other one?
X is element of 2 to infinity.
2 to infinity again.
Mm.
So you're saying that if I have a number line like this, you see, even when you struggle to interpret your answer, you can see that there's something wrong. You are saying that it starts from 1 all the way to infinity, then it starts from 2 all the way to infinity. So what you are trying to tell me is that, so it takes all the values from 1 to infinity, but it's fine. Let's work on this one. First thing first, I'm gonna factorize.
It's negative.
You see?
Is it 1 to minus infinity?
There's only one way to find out. Let's work on this one together, okay?
Okay.
So this is x. I'm gonna put x on both sides, and then the factors of 2 is 2 and 1. Since it's positive, both of them should be what is this? Both of them should be negative. So this tells me that critical values are the values that I get when I solve this equation, which is just 1 and 2. These are my critical values. Then I'm going to put down my number line. And then since the value of a here is positive, my graph will be concave up. Okay, so now I'm just going to say this is 1 and this is 2. Therefore, my graph is concave up like that. So now, after finding the part where your graph is concave up, this is what you do next. Remember, I said choose any number between, but in this case, 1 and 2, I need to choose 1.5. So I don't like to work with decimals. I don't like to work with fractions. So I'll go with this side. I'll choose 0. Right. You take 0, you substitute this on the original equation. So this will be 0 squared minus 3 into 0 plus 2. This gives us positive 2. The solution is positive. So this tells you that this side is positive. Remember, I said if this side is positive, this other side will have the same sign. So this side also will be positive, which makes the middle part to be negative. Then you go and ask yourself, what is the equation? What is the solution? The question asking for, where is the solution greater than 0? Greater or equal to 0, they're asking you, where is it positive? So then when they ask us, where is this positive? We're going to say it's positive from this point moving in that direction, meaning that x must be greater or equal to 2, or from this point moving in the other direction. So x must be less than or equals to 1, meaning that it's from negative infinity to 1, but the 1 is included. Then it's from positive 2, which is also included, all the way to positive infinity. So I think you need more practice on inequalities, okay?
Could you please send me a worksheet?
Okay, I'll definitely do that. I think we can do more practice before you go in an exam. I'll check on the next maths lesson. We'll start with 1 or 2 questions on inequalities, okay?
Okay.
But tell me, do you understand how? So this tells me that you know to get to this part. The issue is finding the final solutions. Do you understand?
Yes.
Okay, let's move. You said, I think this is the last question for question 1, and you said Okay, let's look at the mark allocation. Can you believe that question 1, the mark allocation 27 marks? Just imagine 27 marks. Okay, so now what's going on is that they want you to okay, so the next question, which is question 3, you said you don't have number patterns, right?
Yes.
Did you do number patterns in grade 10?
Yes.
Then you'll definitely get number patterns.
Let me ask on my grade.
You'll
Let me
definitely
ask on
get
my
number
grade.
patterns. So we have to revise this, okay?
Okay.
Right. You'll definitely get number patterns in your June exam. So they say consider the sequence -5, -2, 1, 4, 7. Write down the next two terms of this sequence. The next two terms. First thing first, we need to look at the term, analyze the sequence, and find the difference between these two. So what is the difference here? What do you get when you say, remember, the difference is T2, you minus T1. So this is your T1, this is your T2, and so on. So T2, it's -2, then you're going to minus into -5. What is the answer then?
So the grade group is saying that it's not going to be in our paper.
You say?
I asked on our grade group and they said that it's not going to be there.
But you did number patterns in grade 10.
Yes.
You know how it works. Like, do you have a scope?
Do I have a school?
A scope, the math scope, did they give you a demarcation?
They don't give us demarcations.
Okay, but you see, okay, let me let me just tell you something how this works now. When they set an exam, if you did
Yes.
something in the previous grade, you should expect that thing in the upcoming exam. Look at the grade 12s now. The grade 12, 60% of the June exam is grade 11, but you don't have to do that things in your class, you understand?
Oh, okay.
You don't have to do the number patterns in your class, but they will be there in your June exam since you did the topic in grade 10. So there's no way you write a June exam without number patterns. There's no way you can write a June exam without having functions. You'll definitely get functions. You'll definitely get number patterns. Don't only focus on what your teacher was teaching you this for this term, okay? Even when you have to go and revise term one's work, you'll definitely get term one's work. You'll definitely get, and this is just 6 marks. So let's just do this revision, then we'll move to functions, okay?
I'm so good at functions.
Okay, so are you saying we should not do functions?
No, we can do them, but I'm so good at them.
Okay, so what is -2 into, this will give us what? +3, right?
Yes.
The constant difference here is 3. The constant difference is 3. So this tells you that to find the next term, we need to add 3 to 7, which gives us 10. This will be 3 to find the next term. We need to add 3 to 10 to get 30. So the next two terms will be 10, 30. So these are your next two terms.
Okay.
Okay, tell me, how do we find the nth term of this sequence? How are we going to find the nth term?
You put it into Tn equals A plus N minus 1 D.
So we just have to substitute everything there. The value of A is the first term of the sequence, and the first term was given as what? -5. So I'm just going to substitute -5 plus, and then N minus 1.
Could you please decode the factors? I mean the variables for me. Like, what does everything mean? Tn is term number.
Okay, so A is the first term, right?
Okay.
So this one is the first term. So it's like saying T1. And then D is 3. And this is your common difference.
Okay.
And then N is the number of terms.
Okay.
Then you know that Tn is that the general formula. So is the rule. So now if I solve this, Tn will be minus 5. Then I'm going to multiply out the bracket by 3, which gives us positive 3n minus 3. Therefore, what is your Tn equals to when you add the like terms? This will give us 3n minus 8. Are you happy with that? This is your general term.
Yes, I'm just quickly.
Okay.
Right. Tn equals -5. Okay, yes.
All good. Shall we move now?
Yes. So wait, is that the answer?
Yes.
Okay.
So now they want you to find T25. So when they want T25, remember, your Tn is 3n minus 8. So meaning that if you get this wrong, this will affect the next question. When looking for T25, where there's n, you're going to substitute 25 and put that on the calculator. You'll find what is your term number 25. What is that when you put it on the calculator?
25. Sorry, I just need to revert my.
It's 25 times 3 minus 8. 25 times 3, that's 80, 75. You minus 8, that's 67.
67.
And that's it. You see, that was an easy revision. That was an easy revision. And if I look at this, this is even grade 9's work. So imagine you are writing a June exam, they give you grade 9's work, you still get it wrong. You see, what does that say about you? You did not do your research, you did not prepare well. Remember, I'm not just only here to like tutor you. I'm only here, I'm also here to coach you. So you need to follow my instruction. When I tell you do this, don't go and confirm with your classmates, because your classmates, they are also students. I have 8 years tutoring experience and I know how they set these exams. I've never opened a June exam that doesn't have number patterns. I've never opened a June exam without function, because even function, some of the work, if let's say you get a linear function, that's grade 10s. So they'll try to give you something that we call a wake-up call. Don't only focus on what you are currently doing at school, but you need to do your research. You understand? Let's look at this function. I'm going to look at this function here. Determine the equation of the following graph. So you are given the equation y. It's equals to 2 to the power x minus p plus q. We need to find the equation. So when I look at this line here. At 3, we have the horizontal asymptote. Y is equal to 3. That's the value of q. Without wasting any time, I'll go and substitute that value of q. I'll definitely go there and substitute. But now, before doing that, let's quickly go and substitute. So this will be y is equals to 2 to the power x minus p. We add 3. You're still with me on that?
Yes.
Then you're going to sub in any point. Look at the point that we are given there, 1 and 4. So I'm given the point 1 and 4. So this is your x, this is your y. So on this equation, where there's y, I'm going to put 4, and where there's x, I'll put 1, and this will help me to solve for 1. This will help me to solve for p. So This will be 4. I'm going to subtract 3. This is equal to 2 to the power 1 minus p, which is just 1. It's equal to 2 to the power 1 minus p. So now I need to solve for p. Tell me, what should I do next?
Wait, it's 1 plus p plus 3. Then it becomes 4 minus 3. 2 to the power of...
You understand
What?
the steps that we did here?
Why does it... Oh, never mind.
Okay.
Why does it become minus p?
Why does it becomes minus p?
Yes.
Why is it minus p?
Yes. Why is it becoming 1 minus p?
Oh, okay. Look at this. It's x minus p. That's how the equation is
Oh,
given.
it's
I'm not
x
going to
minus...
change anything. I'll just substitute x, then it becomes 1 minus p. So where there's x, I just put 1. Where there's y, I just put 4.
Oh, okay.
Then now, what will be the next step? Because I'm trying to solve for p. What should I do next?
P is 0, Mus.
Why are you saying p is 0?
I mean, p is 1.
Why is p 1?
Because 2 to the power of 0 is 1.
Look at this. Oh, you're saying that we can change this one, write it as 2 to the power 0, right?
Oh, it's 2 to the power... Yeah, you can write 2 to the power of 0
Equate
equals...
this to 2, 1 minus p, right?
Then
The
it
base
becomes
are the
0
same,
minus p.
therefore solve for p. So the p will
1.
come this side, the value of p is just 1.
Yes.
Then you go back to your equation, you substitute everything this time. So this is y to the power 2, x, we are minusing p, which is positive 1, then we add 3. So this is the equation of that graph. Easy
Yes.
maths. Look at the next question. This is hyperbola function, okay? It's a hyperbola function. And since this is a hyperbola function, you know what you're going to do. You're going to say that you have f at x, okay, f at x, it's equals to, I'm just going to leave the a first over, and then I know that this guy here, the line, which one? This one here, this line here. This is my vertical asymptote. It's x, it's equals to minus 1. Okay, so this is where I need your attention. Then, if you have this type of, this is a vertical asymptote, to know what you need to put on your denominator, you're going to put the 1, bring it this side, so this will be x plus 1, it's equals to 0. Because remember, to find the vertical asymptote, we take the denominator, we equate it to 0. So this will be your denominator, x plus 1. So your denominator is just x plus 1. Do you understand how I got the x plus 1?
Yes.
So this tells you that the value of p is 1. Therefore,
Yeah.
then this guy here, this is your horizontal asymptote, which is just q. So this is y, it's equal to minus 2. So the value of q there will be negative 2. What's next? Choose any point on the graph and find the value of a. Can you do that for me? Will you be able to solve for a? So the question is that which point are you going to choose?
I'm gonna choose 0, 0.
Exactly. There's only one given point, which is 0 and 0. So where there's y, we put 0, and where there's x, we substitute 0. Then the 2 comes this side to be positive. This is a over 1. So the value of a is just 2. Then you substitute back. Say y is equals to 2 over x plus 1, and then minus 2. That's our final answer. That's the equation of this graph. This is easy, né?
Yes.
We were supposed to do something like mixed function. But remember, this is just a startup. So when I look at the next question takes us back to algebra. So this tells you that you get to work on nature of the roots. Let's go back to algebra. Then on our next lesson, I'll make sure that I pick the question paper that has more function revision, okay?
Okay.
Right. So look at this. I don't want to lie. There's nothing easy about this question, né? But we'll try and work on this step by step, né?
Okay.
So first thing first, I will try to work out my problem. Remember the 4. I can take this 4 as 2 to the power 2. Then this is to the power x plus 1. Then I have this as...
could you please give me 2 seconds?
Okay, no problem. Okay, so now, I'm basically trying to analyze this question. I'm trying to find the best way that we can do this, né? But, okay, it's fine. Let me just show you what I have so far. So I think that this, I'm going to leave this as 2 to the power 2x, and then plus 5. I'm going to leave it like that. I need to work this part first. Okay, and we know that this is equal to 3 multiplied by 2 to the power 2 minus x. Okay, so what should we do next? Multiply the exponent. This gives us 2 to the power 2x plus 2. This is where most learners make mistake. They just say 2x. They forget to multiply that plus 1 by 2. Then this gives, oh, nice. Now I can see that I have a common factor. Do you agree with me on that?
Yes.
I do have a common factor now. And what will be my common factor?
2 to the 2x.
Exactly. I can definitely take out the 2 to the 2x. Do you want me to go straight take out the common factor, or you want me to separate these terms first?
Please, can we just do step by step?
Okay, 100%. You see, music to my ears. So this will be 2 to the power 2x multiplied by 2 to the power 2. Do you understand how I got to that part? If I have a to the n multiplied by a to the m, the base are the same. I add the exponent. So what I did, I just reversed the exponent. Just give me a second. Okay, do you understand that part?
Yes, sir.
Where we reverse the exponent.
Yes, sir.
Okay, 100%. Then I'm going to do the same this side. This will be 2 to the 2x times 2 to the power 5. And then this is equals to 3 times 2 to the power 2 minus x. So what's next? 2 to the 2x, 2 to the 2x out as a common factor. Let's see what we get. This will give us 2 to the 2x out as a common factor. I'm left with 2 to the 2 plus 2 to the power 5. And then this is 3 times 2 to the power 2 minus x. Therefore, now I can see that what is 2 to the power 2 plus 2 to the power 5? What do you get?
2 to the power 10.
Wait, no. This is not, this is addition.
Oh, 2 to the power of...
It's like saying 4 plus 32, which is 36, right?
Oh, so you don't... Okay. So you don't say 2 to the power 7?
No. If it's 2 times 2 to the power 5, now that we are multiplying, you can add the exponents. This is addition. So it's 4 plus 32. Are you with me on that?
Yes.
I just need you to relax, né? Even when you write your exam, relax, take everything step by step, and then you'll see. You won't make mistakes. Then this will be 36. So, and this 36, it's equated to what? This 36, it's equated to 3 times 2 to the power 2 minus x. So another thing that you need to keep in mind is that if I have a multiplied by b, the root of this, I can say this is the root of a multiplied by the root of b. So this tells you that I can write this in this form. I can take and say this is the root of, instead of saying 2 to the x, I'll write this as 2x and then everything squared. I'll explain why I'm separating this one. Eh? So look at this. The reason I'm separating this is because I need the square root to cancel with that, because I know that 2 times x is just 2x. So I need to get rid of the square root. Then I'll be left with 2 to the x multiplied by 36. The root of 36 is 6, right? Are you still with me?
Yes.
Okay. Right. So the next step is to just equate this to 3 multiplied by 2 to the power 2 minus x. Okay, let's rewrite this equation up there. Then we'll start working on it step by step, because we are still moving. There's still steps that we need to take to solve this problem. So now I see that I need to, let me rewrite the equation first. You see this part here where I have 2 to the x, which is multiplied by 6. This is equal to 3 multiplied by 2 to the power x minus O is 2 minus x. So now I need to change this 6 to be base 2. The best thing to do that, and the best way to do that, is to divide both sides by 3. Divide both sides by 3. So this is just 2 to the x multiplied by 2 to the power 1. This is equal to the 3 will cancel. I'm left with 1, which is just 2 to the power 2 minus x. So this side, the base are the same. I can add the exponents. And then this is 2 to the power 2 minus x. The base are equal. This tells you that also the exponents are equal. I can equate the exponents. You understand? Are you still with me?
Yes.
Just give me a second.
No.
Remember, the x comes this side. You were supposed to work on this. The x will come this side, is positive, which will be x plus x. That gives us,
It gives you 2x equals 1. X equals 1 over 2.
100%. Ne?
Yes.
Okay, so this will be 2x. It's equals to 1. Therefore, divide both sides by 2. The value of x is just 1 over 2. Ne? That was fast. You did
Is it
this
wrong?
one. Did you do this one?
Yes.
And what's your answer?
P equals 5 or P equals negative 5.
Okay. Let's see. They want the, what is this? They want, for which values of P will the roots be equal? I think we did talk about this last time, the nature of the roots, né?
Yes.
So we said that if the discriminant is greater or equal to 0, the roots are real, right?
Yes.
And then if the discriminant is less than 0, this will be non-real. And then this one will keep going. This one, the discriminant will be 0. Then we're going to have equal roots. And if the discriminant is greater than 0, we're going to have unequal roots. Remember, if it's greater than 0, it's either you're going to have the discriminant as perfect square or the discriminant not a perfect square. Okay, so if the discriminant is perfect square, the roots are rational. And if it's not a perfect square, the roots will be irrational. But in this problem, they said, where will the discriminant be equal? So we know that the discriminant must be 0. And the formula for discriminant is b squared minus 4ac. Then we don't have to stress, because we know that from the given equation, if we can go back up there, from that given equation, let me quickly check this. We're given a formula somewhere here. I did see it. So you can see that what you have inside the square root is the discriminant. So I can take everything inside the square root, equate it to 0, and solve for p. Are you with me on that?
Yes.
So this is just 25 minus p squared. Equate that to 0, therefore 25 will be what? P squared, square both sides, and the square root of any number is plus or minus 5. So that's what is p is equal to, plus or minus 5. Is that what you got?
Yes, but I did it differently.
How did you work on this one? Did you factorize?
Yeah, I used difference of two squares.
Okay, 100%. So now we need to discuss the nature of the roots if p is 3. So on the discriminant, we said the discriminant is what it's inside the square root, which is 25 minus p squared. So where there's p, we substitute minus 3 and see what we get. So this is 25 minus into minus 3 minus into minus 3, and this minus 3 is squared. So I think, tell me, what is this equals to on your calculator?
16.
You got 16, right?
Yeah.
So look at this. What type of number is 16? 16 is a perfect square, and we said that if 16 is a perfect square, the nature of the roots, it will be rational, but you need to give them everything. So it will be rational, then you move up. This is for real, right? It's rational. If we keep moving, the roots are real roots. So it's going to be real plus
And
rational. Okay?
will they not also be equal?
Yes, you can say unequal. Then
They'll be unequal. Will they not be equal if 16 is a perfect square?
no, it will be unequal.
Okay.
Then we're gonna have rational, and then the last one real. So this will be real roots. Is that making sense? Look at
Yes.
this. This one is unequal. So you start from this part, which is rational, you move up, you get unequal, you move with the map, then you stop at where? Real root. So it's 1, 2, 3. You want to try the next one? But
Yes,
before
please.
that, do you have a question on this one?
No, thank you.
Do you want to try work on this one? Because this is exponents, ne?
Yeah. Yeah.
Okay, I see the question paper is still going. But yeah, try work on this one. You'll tell me what you get, ne?
Okay.
Get
I got -1/5.
-1/5.
Yes.
Okay, let's work on this one step by step and see what we get from this one, okay?
Okay.
-1/5. So, okay, so I think what I'm going to do first here is to first, you still remember that law that we were using
Yes.
of separating this exponent. So this is the law that I'm gonna go with. I'm gonna first write the top part as 3 to the x minus 3 to the x times 3 to the minus 2, so that I can be able to take out the common factor, né?
Yes.
So let me apply the same thing this side. So I'm gonna have 3 to the x, this is times 6, minus 4, multiplied by 3 to the x times 3 to the minus 2. So the top part has a common factor of what? 3 to the x. So this will be 3 to the x into 1. So where there's 3 to the x, you replace that by 1, because we have it out as a common factor. So this will be
Is it
1.
not supposed to be replaced by -1?
Is it?
Is it not supposed to be replaced by -1?
No, 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 no. We
That's what,
replace that by positive 1. Then the one that will be -1 is this one. So this will be -3 to the power minus 2. Do you
okay, so
understand
now,
that part?
but why?
Listen, when you take out the common factor, when you multiply out the bracket, you should get the same expression that you got when taking out the common factor. You understand?
Yes. So my answer is actually 1/50 then.
It's 1 over
50.
1 over 15.
50.
50. Are you saying 15 or 50?
50.
Oh, okay. Right. Let's continue working on this. Let me see what I have here. So this will be, I'm just going to take out the common factor even on bottom. This is 3 to the x into 6 minus 4 times 3 to the minus 2. So the 3 to the x cancels. The top part will be 1 minus 3 to the power 2, which is 1 minus 3 squared, which is 1 over 9. And then divide this by 6 minus 4 over 9. Because they said simplify without using a calculator. So I need to take this step by step, okay? You understand?
Yes.
Are you still with me?
Yes.
Okay. So the top part, when I work out the top part, this will be 9 over 9 minus 1 over 9. So I can just write this as 9 minus 1 over 9. You understand? The denominators are the same. I can just jump here and say, this is grade 9, né? This is grade 9's work. So I can say this is the same as 9 minus 1 over 9. Do the same this side, which is 9 over 9. What is 9 times 6?
40, 60, 54.
It's 54 minus 4 over 9. So this tells you the top part, it's 8 over 9. The top part is 8 over 9. Everything is divided by, what is 54 minus 4? That's 59.
Over 50 over 9.
Over 9. which is 8 over 9. I'm going to multiply this by the reciprocal. The 9 cancels. This is 8 over 50. So 2 goes into 8 how many times? 4 times. And then 2 goes into 50 25 times. That's the answer. Did you take this step by step?
Yes, I did.
Okay. What's wrong? You're tired?
Very.
I think I'm gonna leave this one as your homework. You can try work on that one. I'll give you the solution. Let me help you with this one.
Okay.
Okay, so the lot that you need to understand when working with the sets is that if I have a to the n and this one is m there, I can write this as a. Whatever exponent that you have inside the set becomes your numerator. Whatever that one you have outside, it becomes your denominator. So I can change the first part, write that as a minus 3, or it's a minus b, everything to the power. This will be 3 over 3. And this is multiplied by a minus b to the power 3 over 3. Do you understand that part?
Yes.
The denominator does the difference of squares. I'll have a, b, b, one bracket positive, the other one negative. If this one is positive, the other one will be negative. The 3 cancels on top. The top part is just a minus b multiplied by a minus b, everything divided by a plus b into a minus b. So you cancel the like terms. This leaves you with a fraction of a minus b over a plus b. I think this was easy, né?
Yes.
I'm gonna leave this one and do the last nature of the roots, né? This one you can work it, try to practice this one on your own. Then I'll give you the solution. Let me explain this one, né?
Yes.
Then we can call it a day.
Yes.
For which values of k does the following function have real roots? You see, this question is coming back. We said for real roots, the discriminant must be greater or equal to 0, right?
Yes.
So the discriminant, it's b squared minus 4ac. But this equation is not in standard form. We need to first put the equation in standard form, which is 2x squared minus 8x plus 6 minus k, this is 0. Right. So the discriminant must be greater or equal to 0. The discriminant, it's b. What is the value of b?
B is -8.
-8, and this will be squared minus 4 into a. The value of a is 2, and the value of c. What is the value of c?
It's, the value of c is 8, is 6 minus k.
Exactly. You take everything that you see that 6 minus k must be greater or equal to 0, then you solve for k. So this is 8 squared, that's 64, minus 2 times 4 times 2, that's -8. So I need to multiply the bracket by what? By that -8, which gives me -8 times 6, that's -48, and then plus -8 times -k, which is positive 8k, greater or equal to 0. We add the two numbers. What is 64 minus 48?
16.
What do you get when you say 64 minus 48?
16.
Please come again.
16.
16.
Yes.
Plus 8k greater or equals to 0. Therefore, I'm going to move the 16 to the other side. 8k greater or equal to minus 16, divide both sides by 8, which gives us the value of k to be greater or equal to minus 2. And that's it for this one.
Oh, okay.
Oh, shucks, we do have a mixed functions. We do have a mixed function, but that will be for the next lesson. Ne?
Yeah.
Can you see this question? We'll answer that on our upcoming lesson. Ne?
Okay.
Okay, and that's it for this one. Do you have any question based on what we've discussed today?
No, thank you.
Okay, great. Have a great day. I'll see you on the next one.
Nice one. So I'll see you tomorrow. Bye.
Sharp, sharp.